A new book from E.O. Wilson commands respect, if only because two of his old books won Pulitzer Prizes, which is a record. Wilson is an ant biologist with big ideas. His new book, called The Diversity of Life, has been compared to Rachel Carson's book about DDT, Silent Spring. But Wilson's book is actually a much broader notice that humanity is tearing up the seedbed of life that took millions of years to evolve. We went over to see Edward Wilson last week in his Harvard laboratory with the ants that first made him famous.
These ants, they're not able to go at full speed on this rather narrow bridge, but when they go out looking for leaves, they are traveling at a pace which, if they were a 6-foot-tall man, would be roughly equivalent to 345 miles. In other words, the current world record for the mile going out. They pick up 500 pounds. Here's one with a 500-pound load right here coming up. They pick up the equivalent of a 500-pound load and go back to the nest at the equivalent speed of about a 4-minute mile, and they do it for distances of up to 100 meters, which is the equivalent of a full marathon back. So they're quite prodigious. Well, they get back into the nest, and then they turn over the leaves to smaller workers, and then on through the assembly line to still smaller workers. And that's how this is all organized.
What is the crisis in the world today about diversity?
We tend to overuse the word crisis, but I think we have a genuine crisis in biodiversity. And it's essentially that we're destroying a large part of the biological diversity of the Earth, and we're doing it within just a few decades. In the rainforest alone, for example, I estimate that if we keep cutting that habitat down at the current rate, during the next 30 years we will have done damage that would result in at least 20% of the species living there being lost. The reason why this is so critical is that of all the environmental secular changes that are going on, this one is the only one that's irreversible. It's the only one that's going to be thought of with great regret by our descendants 50 years from now, 100 years from now, 1,000 years from now. And it's also the one which, if properly addressed and combined with economic initiatives, can produce a whole new source of wealth.
How would you address it? And can it still be addressed?
Yes, I like to make just a very rough ballpark estimate by saying that if we do nothing about the current reduction of natural habitats, rainforest, coral reef, grassland, and so on, around the world, for the next 30 years, we'll lose at least a fifth of the species. If we take appropriate measures, we can reduce that loss to, say, 10%. And why I think we can do this in a manner that satisfies persons of virtually all cultures and ideological background is the promise that this diversity offers us in the form of biological wealth. I think that we need to join more solidly the setting aside of natural reserves, of planning the zoning of areas in biologically rich areas, that is, areas with large faunas and floras, with economic initiatives that make use of the species there as sources of new products, new crops, new fibers, new petroleum substitutes and the like, as a point of interest in ecotourism and so on. And by thinking of economic development and of the conservation of biodiversity as two parts of the same thing, that is, of being completely interdependent one upon the other, we can devise local solutions to the biodiversity problem.
Step back. Everybody worries in different ways about killing the earth. But people worry about so many different things. Aerosol cans in the ozone, they worry about oil spills, they worry about shopping malls paving America. From your view, in terms of the diversity of life on the Earth, who are the real dangers? Who are the real bad guys?
Most of the threat is in the tropics. I don't want to devalue any of the conservation efforts, nor mute our perception of crisis in some parts of the temperate zone, as for example the old stand forest of the Pacific Northwest. But it's a very important consideration that the vast majority of species of organisms live in tropical countries, and particularly a few environments such as the rainforest, the savannas, and the coral reefs. And that is where the greatest environmental destruction is now occurring. That destruction is in the form of habitat loss. That is clearing of the forests themselves, the plowing under of the rich heathland and savannas, and then in many other parts of the tropics, the introduction of exotic species, from big predatory fish like the Nile perch in Lake Victoria to pigs, rats, and so on, and exotic weeds into these natural environments, sometimes inadvertently, with a result that yet more native species are eliminated, even where the environment hasn't been completely removed. If we are concerned with the global picture of biodiversity, of saving and maintaining and gaining benefit at maximum levels, we have to concentrate especially on third world countries in the tropics.
Describe what is lost when a species goes.
A great deal. Just to give you a feel of just how much genetic information is piled up over those hundreds of thousands of years, we could consider the content in a single cell of ordinary organisms, say an ordinary mouse. If you took all of the DNA, the genetic code, out of a single cell of one mouse, and you took that molecule and spread it out. You couldn't straighten out the double helix, but you could straighten out all the secondary coils that allow the material to be packed into the nucleus of the cell. You straighten it out and you put all the strands end on end. You'd get a molecule about a meter long, but it would only be a few nanometers, billionths of a meter across, so you couldn't see it. If you enlarged it now, magically, until you could see it clearly, say it was at about the width of a piece of wrapping string, your molecule now would stretch nearly 1,000 kilometers. And if you walk that length, 1,000 kilometers along your genetic code, you would be reading off about 20-odd genetic letters every inch. That's how much you lose when you lose a species. Every species is a masterpiece.
If I could be the devil's advocate just from what I read in your book, you give a lot of reasons not to worry so much about diversity. Krakatoa, for example, volcano destroys the island, but 100 years later, it's almost indistinguishable from the islands all around it. You also make the point that 99% of all the species in all time are dead, that there's this incredible regeneration of life, experiment. I mean, the evolution continues all the time. New species are being formed all the time. Also, that the world has recovered from these terrible crashes of species from meteors or volcanoes in the past. So, in a certain sense, one can read your book and say, well, it's a rough process, but it's also immensely creative too. What's to worry?
I wrote the book to convey exactly the opposite message. The answer is we should worry ever more. Let me touch on just those points that you raised. It's true that once in a while a great volcanic eruption, several a century the size of Krakatoa, blows away several square kilometers of natural environment, and then that is regenerated rather quickly. Krakatoa, incidentally, probably had no species limited to it, no endemic species, so no species became extinct when it blew up. But the important point is that when humanity came along, we started eliminating area of natural habitat comparable to Krakatoa every few hours, whereas a Krakatoa only comes along once every few centuries. And it is true that 5 times in the last 500 million years, there has been some cataclysmic event, like apparently the meteorite strike that brought the age of dinosaurs to a close 66 million years ago, causing biodiversity to dip precipitously, and then evolution brought it back. But the important point is that it took, in each one of those cases, about 10 million years for evolution to restore it completely. If our descendants are to be told that they must wait 10 million years to replenish by natural means what we are destroying in a few decades, they are going to be very peeved. So we are not, in any sense, part of the natural process. Something is happening today that has not happened for 66 million years. And moreover, we are destroying the source of the creation. If humanity takes over the globe to such an extent that only a small number of natural environments are left, the cradle has been essentially removed. The source of new evolution destroyed. And even if we waited 10 million years, it wouldn't be coming back natural diversity the way it has in past geologic times. You know, a major consideration in the reduction of natural ecosystems like old-growth forest that has not been properly understood up to this point is the rather exact relationship between the area of a habitat, such as the size of a lake or the size of a patch of rainforest, and the number of species that can survive in it. As you reduce the area, you reduce the number of species that can survive in it. If you cut down 90% of a rainforest, or as has happened in many places around the world, or reduced savanna or coral reef by 90% of its area, down to 10% now remaining, you will eliminate immediately or doom to early extinction about 1/2 of the species that live there. And let me just illustrate this area diversity problem by an individual that I brought along that has a particularly poignant history. This is from the Museum of Comparative Zoology, this specimen here at Harvard. This is a male of the imperial woodpecker. It lived in Mexico. It's the largest woodpecker in the world. It was a magnificent bird. It became extinct about 30 years ago. It passed into oblivion 30 years ago. Here is a bird which could have been a flagship species like the panda, the harpy eagle, or the grizzly bear. It disappeared hardly without notice. There were 2 individuals left in the early 60s when one of them was shot and eaten by a Mexican truck driver, later interviewed. He said, it was un gran pedazo de carne, a great piece of meat. That's how that species finally became extinct. But the stage was set by the reduction of the area of the habitat, which is old-growth pine forest. And as that forest was cut more and more, the numbers of imperial woodpeckers that could survive was reduced more and more. Finally, we were left with some stretches of primitive pine forest in Mexico, on the Mexican plateau, but they weren't enough to maintain a viable population of this bird. And then when to that were added the shooting out of individuals here and there, the species was doomed. Much the same story occurred with the American ivory-bill woodpecker, which is extinct in the United States. As its habitat of old-growth forest in the southeastern United States was reduced, there were still national parks, state parks, swampland areas which were suitable for the ivory-bill. But the area, upon being reduced, brought the populations down to a level where they became precarious, and anything else, hunting, disease that might sweep through, anything of this sort, would be enough then to push the species over the edge. Now the ivory bill survives in one tiny population in a forest in eastern Cuba, and we kind of hope that it can be held on to there. But the imperial, the biggest of all, is gone forever.
You could cry about that one.
We have to understand that the same thing is happening to countless other species. I estimate conservatively, very conservatively, with methods of estimation that I've passed by the most skeptical of my colleagues, and they have no objections to this level. I estimate that on the order of 20,000 species of organisms are being lost in the tropical rainforest alone due to that area reduction every year.
20,000 per
20,000, not of all species of plants, animals, and smaller organisms are being lost minimally every year.
Some of them, to be fair, are microscopic.
Oh yes, that's my point. We don't pay any attention to those 20,000. We can identify quickly with an imperial woodpecker. We have a hard time identifying, say, with a leaf beetle or an ant. But we should bear in mind that as our biological knowledge expands, as an appreciation of natural history grows, as the economic uses and the aesthetic uses of these organisms becomes a reality, then in time, if not you and I, then our immediate descendants will come to regard the passing of these smaller and right now seemingly lesser organisms into extinction almost as much as we could regret the passage of a great bird like this.
This is a passionate book, and it's also full of fascinating hints of autobiography. I wanted to ask you, first, how many species do you know on a first-name basis? But I also wanted to ask you how you came to this work.
Well, to answer the first part first, a lot, but then I'm a biodiversity freak. In fact, it was my devotion to natural history and to the study of diversity for its own sake. Going back to virtually my childhood, I began collecting butterflies when I was about 9 years old, and it went into my bug period that every kid does. I just never grew out of mine. That led on to a career, actually, in what I guess could be characterized as study of biodiversity. So I know a lot of different kinds of organisms. I'm right now working on the largest genus group of related species of ants in the world, with probably 1,000 species to cover. I'm very much in the position of David Stark Jordan, who was an expert on fishes and the president of Stanford around the turn of the century, who said he never tried to learn the name of a student because every time he did, he forgot the name of an organism. And since I don't have a photographic memory, I'm almost in that position. But because I had that, shall we say, concentrated, specialized background that led me up to this perception, both intellectual and emotional, of the biodiversity crisis, I thought that it would be important to introduce autobiographical elements into the book, The Diversity of Life, in order to illustrate how naturalists, particularly professional naturalists, feel about their subject, what it is that impels them to look at it a certain way, and what it is that they see of the adventure of physical exploration of the planet's surface. Because make no mistake, this planet is physically still unexplored. We know where all the rivers are. We've put a name on virtually every mountain everywhere. We have coast and geodetic surveys accurate to an inch, but we don't know the organisms that live on this planet. I doubt if as many as 10% of the different kinds of organisms have so much as a scientific name. Oh, to be sure. We know, say, 95% of all the mammals. We may know 95%, although the percentage may be lower, as low as 90% of all the bird species. We know perhaps 3/4 of the flowering plant species. But of all the other organisms, in most groups, we know very little indeed. We're still discovering new species of whales. The last whale, a beaked whale from the eastern Pacific, was described last year, given a scientific name last year, and observers have seen yet another species of whale in the eastern Pacific swimming around, not yet caught and given a scientific name. There may be as many as 5,000 species of bacteria in an ordinary pinch of forest soil everywhere in the world, varying from one locality to the next. Virtually all those 5,000 species of bacteria in a pinch of soil are unknown to science. No name, no characterization. We are still on the edge of a great adventure. This is still a field in which you can go out and get muddy boots and snake bit and see a mountain ridge with a pioneer's eyes. And that's what I wanted to convey, was that we're on a wonderful planet, that we have adventures of the 16th century kind awaiting us, and that's just part of the immense joy and pleasure that can come from humanity, quite apart from its economic benefits in the study of biological diversity.
There's a wonderful line in the book, which I think I can find it early on, not the language you associate with scientists. You speak about being out there in the field and feeling this was wilderness in the 16th century sense, as it must have formed in the minds of the Portuguese explorers, its interior still largely unexplored and filled with strange, myth-engendering plants and animals. From such a place, the pious naturalist would send long, respectful letters to royal patrons about the wonders of the New World as testament to the glory of God. And I thought, this is you speaking, there is still time to see this land in such a manner. Interesting for a scientist.
Yes, but this is the way scientists really feel.
In a general way, Darwin and evolution were thought to have taken God, taken mystery out of the process. And yet, you clearly still find mystery and a kind of, I don't want to say religious, but certainly a kind of awe and excitement still in it. Mm-hmm. Do you not?
Yes, I do. And I think the reason is that it is the very complexity of life, and that a great area of mystery arising from a barely perceived but not yet understood domain of living phenomena that helps to generate the idea of God and the belief in God on the one side, but for the purely scientifically minded and devoted objectivist scientist can generate a similar sense of awe and wonder. Thus, the wellsprings of the feelings that give rise to much of religion, much of religious emotional feeling, and the exhilaration from confronting nature that goes with scientific exploration, the wellspring is the same. And the more that we come to understand life and explore it on the one planet we know it to exist, then the more that theologians and scientists will have to talk about. In my view, their common ground of discussion is not in time zero in the creation of the universe, which has captured the attention of most thinkers in the area, but in the near miracle of life itself.
Do you talk with theologians about these things?
In fact, here at Harvard, we have begun a dialogue between theologians and scientists, at least a few who have an interest of the kind I've been describing. Last fall, I had the honor of being the first scientist to give Harvard's oldest lecture in theology at the Divinity School, the Dudleyan lecture. And the dean of the Divinity School, Ron Tiemann, and I have discussed often a way of joining these concerns. One of the participants in our discussion, incidentally, has been none other than Al Gore. He's was scheduled to join us one more time on a panel next month. I'm afraid he's likely to be an absentee because of his current activities. But no, we see what someone has called a greening of religion, but it's occurring, and a new interest in religion on the part of scientists. But it's, I think, more profound and promising thanks to our evolutionary understanding of life than was previously the case.
Are you still in the field?
Yes. I might be getting a little along in years to be doing that sort of thing, but I make it a practice to go back once a year for a week or two, at least, to the rainforest, Amazon or Costa Rica, and just to luxuriate in a rainforest setting. I do research, but I enter the rainforest the way an art curator would walk through the Musée d'Orsay or the Louvre, just for the sheer rainstorm of impressions that one finds walking along a rainforest trail with your eyes open.
Well, keep doing it, and thank you very, very much, Ed Wilson.
Thank you, Chris.
Next week, I'll be in a different sort of company. The lawyer Margaret Burnham and I will explore the issue of race with a lot of interesting people from the GBH audience. Our one-hour program will be called Color Bind. I'm Christopher Lydon. Good night.